Okay guys, so here's our second slide on solving rational equations. In number 4, as I scan through my denominators, the first thing that I notice is that the middle denominator can be factored to p plus 1, p minus 1. The last thing that I want to do is take that final term and put it over 1. I find that really helps. Now I'm going to construct the LCD. And the LCD of all three denominators is going to be p plus 1, p minus 1. Which is the same as p squared minus 1. Now I'm just anticipating the amount of space that I have here, and it's not a whole lot, so I'm going to switch to another color here just so we don't get confused. So I'm going to set up my three new fractions now, each with this LCD of p plus 1, p minus 1. Okay, going back to the numerators, figuring out what we're going to need to introduce to get to this LCD. If I look at my first fraction, I have a denominator of p plus 1, so I'm going to need to introduce a p minus 1. So again, when I multiply a binomial times a trinomial, I'm going to have to either use the clamshell method or the vertical format method. So I'm going to go off to the side and do that. So I'm going to distribute the p into the p squared, the negative p, and the positive 1, getting me p cubed minus p squared plus p. And then I'm going to distribute the negative 1 through, getting me negative p squared, positive p, minus 1. And when I add these columns downward, the result of that is going to be the numerator of our leftmost fraction. So we're going to be left with p cubed minus 2p squared plus 2p minus 1. Okay, now we're going to move to the second fraction, and the second fraction's denominator isn't missing anything to look like the LCD. So I'm just going to leave the numerator alone, p squared minus 7. Now we're going to look at the rightmost fraction, and the rightmost fraction currently has a denominator of 1, so it's really missing both the p plus 1 and the p minus 1. And perhaps the best way of thinking of that is going to be p squared minus 1. So I have to introduce p to p squared minus 1. And I'm going to distribute the p into the p squared and the p into the minus 1. And when I do this distribution, I get p cubed minus p. Okay, now the fun part begins. I'm going to eliminate the denominator by drawing a red line through it. And I'm going to solve the resulting problem in the numerator, the left side of which is p cubed minus 2p squared plus 2p minus 1. And the right-hand side, if I write it in descending exponential order, is p cubed plus p squared minus p minus 7. Now I notice that the p cubes on both sides are going to cancel out. So I notice now that I'm left with a quadratic. And the first step in solving a quadratic equation is to set it equal to 0. So I'm going to move everything to the left-hand side. When I do that, I'm left with 3p squared minus 3p minus 6. Now I'm going to divide every single thing through by 3 to just make the numbers easier to work with. And now I'm going to factor the resulting quadratic as p minus 2, p plus 1. And finally, I'm left with p equals 2 or p equals negative 1. Now it's critical that we check to make sure that when we plug back into the original, we don't end up with 0 in the denominator. And I notice right here at this first fraction, if I plug in p as negative 1, I'm going to end up with 0 in the denominator, which would produce an undefined situation. So we're going to reject that answer as an extraneous solution. So the only answer for question number 4 is 2. And I've gone all over the place here. I've really spilled into the other areas. So I'm hoping to be able to finish this without being too confusing. So let's take a look at number 5. And the first thing that strikes me, there's actually a couple of things that hit me, and that is the denominator on the right can be factored as y plus 2, y minus 2. And then I notice in the middle fraction that we have a 2 minus y. Well, 2 minus y and y minus 2 are almost the same, except that they're exact opposites of each other. So what I'm going to do is I'm going to reverse 2 minus y, and I'm going to call it y minus 2. But for me to legally do that in the land of algebra, I have to extract a negative. And if I extract a negative, it's going to join with this negative that's already here and turn it into a positive. So I'm going to cross that out, and I'm going to put a plus here. So that's a really advanced maneuver, but it's one that happens a lot in dealing with rational expressions and equations. So my LCD here looks like it's y plus 2, y minus 2. And I'm going to go ahead and rewrite each of the three fractions with that LCD. Okay, so if I look at the leftmost fraction, whose denominator is y plus 2, I want to ask myself, what am I going to need to introduce to that to get to that LCD? And I need the y minus 2. So 2 distributed into y minus 2 is going to be 2y minus 4. Now if I look to the middle fraction, the denominator is currently y minus 2. So I'm going to need to introduce the y plus 2 in order to get to the LCD. And if I distribute a y into a y plus 2, I'm left with y squared plus 2y. And if we move all the way over to the right, we've got this denominator of y plus 2, y minus 2, which is the LCD. I don't have to introduce anything. So I'm going to leave the numerator alone, and I'm left with y squared plus 4. I cross out the denominators, and I solve the problem in the resulting numerators. And this is going to be, let's see, if I put it in descending exponential order, y squared plus 4y minus 4 equals y squared plus 4. The y squareds drop out, and I'm left with 4y equals 8, or that y equals 2. Now if I do a quick check, I very quickly learned that if I let y equal 2, that the middle fraction doesn't work, nor does this fraction over here, because if you plug in 2 for y, you're going to end up getting 0 in the denominator, which is an undefined situation. So I'm going to cross this out. Y equals 2 is extraneous, and what that means is, because it was our only answer and it doesn't work, that means that in the end, there is no solution to number 5. So we're going to write no solution, but we really need to include in our work the fact that we got this answer of 2, but that it doesn't work. Okay, let's move to number 6. The first thing that I notice in number 6 is that this ends with a 1, so I'm going to make it 1 over 1. Alright, now I'm going to identify my LCD, which will be z minus 2, z plus 1. And I'm going to prepare to rewrite my three fractions. Okay, so if I look to my fraction to the left, I've got a z minus 2, and what I'm missing is the z plus 1. And if I distribute 4 into that, I get 4z plus 4. Now if I move to the middle fraction, I've got a denominator of z plus 1, which means I'm missing the z minus 2. This is going to require foiling, and I end up getting z squared plus 4z minus 12. Now let's look at our final fraction, which has a denominator of 1, and this is missing both elements to get to the LCD, so what it's missing is a z minus 2 and a z plus 1. And if I FOIL those together, I get z squared minus z minus 2. Let's cross out our denominators, and let's write an equation with our resulting numerators. Now I need to caution you that if we look in the middle, there's an expression preceded by a negative. So that negative is going to negate each term of this trinomial in the middle. So we're going to be left with 4z plus 4 minus z squared minus 4z plus 12 equals z squared minus z minus 2. Cleaning the left-hand side up, we get, I noticed that the 4z and the negative 4z cancel out, so I'm left with negative z squared plus 16, and that is equal to z squared minus z minus 2. This is a quadratic equation, so I know that I have to set everything equal to 0. And this is going to leave me with 2z squared minus z minus 18. And if I do a quick Nobes analysis or factoring analysis, I realize that this cannot be factored. So I'm going to have to use the quadratic formula. Z equals negative b, which would be plus 1, plus or minus the square root of b squared minus 4ac all over twice a. And this turns into 1 plus or minus the square root of 145 over 4. Now the factors of 145 are 5 and 29, neither of which are perfect squares, so I can't break this down any further. And clearly, if I were to plug these in for z, I'm not going to get an undefined situation. So these problems are very, very complicated, and we have to do a variety of things like multiplying using the clamshell or the vertical format method. We have to switch denominators around from 2 minus y to y minus 2, and we might even have to use the quadratic formula. So really, be prepared for anything.